1.1 and talking about key features. Okay, so some of the vocabulary you'll be familiar with already in terms of increasing, decreasing, positive, negative, but we're going to look at that in relation to graphs. We're going to bring back some words like domain and range. Those are words you've seen, you've heard, you've used. It's just a matter of how, getting to the point where we remember them. But before we do that, we're going to use this example to kind of get us in the math frame of mind and talk about some pieces here. So, sorry, the picture I know is a little dark in the copies, but I have it up here to look at too. A diver is going through ocean search and rescue training. The graph shows the relationship between her depth and the time in seconds since starting her dive. So you have the graph in front of you. We're going to look at some questions. What details can you determine about the dive from the coordinates of the point 5, -8? Thoughts there? What does 5, -8 tell us about this dive? Based on all of your clues.
She's going down 8 feet every 5 seconds.
Partially. Can we agree with the labels he gave? We've got 8 feet, 5 seconds, right? There's a slight catch, which is why I'm not 100% agreeing. Oh my gosh, this is driving me crazy. Your name has poofed out of my Lucas. There we go. I don't even have the right scene chart up. It just poofed back in. What else? And there's one other key that we'll get to at some point here, but the only thing I'm being, I don't know, am I being nitpicky? It's not that she went down 8 feet in 5 seconds. That's where there's a little bit of a catch there. But what does this point represent?
How far I went down?
Okay. She is what, 8 feet? Why is it -8? 8 feet below the surface of water, right? And how many seconds are we into this dive? 5 seconds, yes? Okay, so I'll go with that to get us started. And we'll have to talk when we get to the next one about why I'm not 100% sold on the fact that she went 8 feet in 5 seconds. I know, it sounds a little different, but now, normally I give you lots of space to write. I didn't leave very much room here just because I took this problem from the book, but what I'm going to put here, you can write as much or as little as you want when I write stuff down. But the fact that the diver reached, 8 feet, the lowest point of the dive at 8 feet, and that was 5 seconds after beginning the dive. Okay. I'm going to say the diver reached 8 seconds below water. Yeah. Thank you. Definitely not seconds. I don't know what I'm doing there. Gosh. 8 feet below water, and then I'm going to say 5 seconds. Goodness. Into the dive. Now, start looking at B. Because B, I need you to pick up on there's a piece of information we haven't picked up on yet. Okay, so B asks us what is the average speed of the diver in the water, and how can you tell from the graph? Okay, what are you thinking, Lucas?
2 feet per second.
Why 2 feet per second?
Because there's 2 feet on the surface and 8 feet under the surface.
Okay, so earlier we talked about 8 feet in 5 seconds. She traveled more than 8 feet, didn't she? Why did she travel more than 8 feet?
Because she started above sea level.
Yeah. Did she start at the water level at 0? No, she started up here, and that's what you have to catch. Actually, she started up here and traveled down there. Okay, and so that's where I was waiting for that extra piece of information to be pointed out here, that she didn't just travel 8 feet in 5 seconds. She technically started at the boat, right? Started the boat, which puts her 2 feet above the water, according to this. Okay. Now, how did you get, I think, Lucas, you said 2 feet per second, right? And how did you get that?
10 divided by 5.
Okay, 10 divided by 5. The fact that you travel from 2 feet above to 8 feet below, that's a distance of 8 feet over 5 seconds. What does this relate to in algebra? What are we finding here? Yeah, we called it the average speed, but if I give you 2 ordered pairs, such as the ordered pair we already have, 5, -8, what would this ordered pair be? Left, right, 0, and up 2. What could you find using those 2 points? What's the algebra word here?
Slope.
Yep. You guys remember doing slope?
Yeah.
I think this morning I said something about change in y over change in x, but someone real quick came back and said instead, do you guys know it is y2 minus y1 over x2 minus x1? Does that sound familiar? Mm-hmm. Okay, you've done slope. You probably used it in geometry along the way, I'm guessing, but you definitely did it in algebra. So if we do something like that, y2 minus y1, so 2 minus -8 over 0 minus 5. There, that difference between 2 and -8. 2 minus -8 is 10. 0 minus 5 is -5. 10 divided by -5 is -2. Why is it negative? Is it okay that it came out negative? Why did it come out negative? Because what's she doing?
Going below.
Yeah, she's diving down, right? Okay, we're in a downward motion there. Okay, so it makes sense that it comes up negative. Now, the question was, what is the average speed? The average speed, I'm still going to say, is 2 feet per second. Okay, we don't traditionally put a negative on a speed. Okay, the negative just indicates the direction, so it indicates that she was diving down. Okay, we could also throw in the phrase rise over run if you wanted to. Okay, don't worry, we'll get into some slope review at some point. Okay, we've kind of already addressed C. Which point on the graph shows the starting location of the diver, and explain? Where's the diver starting? What point was that? 0, 2. And what? That 0 represents? What's 0 represent? It's 0 seconds, and 2 is the 2 feet above water. Okay, above the water level. So this is just the 0 seconds, 2 feet above the water. Okay. And finally, D. And I will say, a lot of my answers, I have them written in between the lines. I just wrote really small. I just can't really do that up here on the BenQ. It just doesn't fit the same. D. What does the V shape of the graph tell you about the dive? What information does it not tell you about the dive? What's the V shape telling you? No?
Is it because there's like, it's going like diagonal, so it's not a straight down distance? It's more distance.
Okay, so the Yeah. So the fact that it's going down, it's not going straight down. Okay. And that's going to represent the going down. The other part of the V is going to represent going up. And again, when you dive down and dive back up, do you necessarily dive straight down and straight up? No. I feel like I'd maybe dive more straight up than I would straight down, but okay. What information, with that in mind, does this not tell us? Does she go in this exact shape? We just know that the starting point, and then 5 seconds later, she's 8 feet below. Did she dive straight down there? Okay, not necessarily. Okay, and that's something we don't know. Okay, that path is not necessarily representing exactly our path. Okay, but it's the idea that, you know, what do I want to say here? Did she swim at that straight angle? Was there maybe a brief horizontal or something before she continued, right? You know, as the water buoyancy tries to kick you back up. So those are some things to consider there. I'm trying to remember what all I had written down here. Generally, the V shape, the diver dove down, swam back up. What we don't know is, you know, exact path. Did the diver ever swim horizontally? That would be a big key to think about. So I'm going to put on here, diver dove down, swam back up, and then the question I'll put is just in general about the path, but did the diver swim horizontally? And I'm out of room there, so I'm just going to put swim horizontally, question mark. Again, traditionally you have a lot more room than this, so if you're squeezing it in thinking, oh, well, this is going to be a long year, you don't always have to squeeze things in quite this much. Okay, guys. Trying to get you looking at a graph, trying to get you start talking about the aspects of the graph. Like, we didn't put the words there, but we just talked about decreasing and increasing. We just talked about positive and negative. And those are some of the places we're going here. Okay, at the bottom of your front page, couple of things. First of all, domain and range. I know I have a definition up here, not necessarily the definition you know. What do you guys remember about domain and range? Claire?
Didn't domain only apply to X while range applied to Y?
Okay, when we talk about domain traditionally, the domain values are the X values, and the range values are the Y values. Okay, so a lot of times we talk about an ordered pair. The first number in an ordered pair is domain. The second number is the range. And keep in mind, in an ordered pair, it is X comma Y. Okay, now up here, domain, the set of all possible inputs for a relation. So your X value is your input. You put it into an equation, a function, whatever. The range, the set of all possible outputs for a relation. As I said, we generally think about it as the Y values. Okay, so when we get to the next page, we are going to look at some graphs and talk about domain and range and exactly what that means. Another chart here that just to kind of familiarize and give you some examples. We're going to talk about two ways to express answers. Okay, we're going to talk about set notation, which set notation, it uses inequality symbols. When we talk about inequality symbols, the less than, the greater than. Those are the symbols you already know, right? So we're going to be talking about this. Now, they call it set notation, and really you just get this extra formal piece of how to express the answer. I'm going to show you that and familiarize you with it. But I'm just going to be looking at, can you write a basic inequality? Okay, that's, you know, when it comes to grading you, that's what I'm looking for. But these are ways to express set notation, inequalities. Interval notation is probably the newer part. because that uses things like parentheses and brackets, and that's what you see over here. Okay, so I'll be introducing the interval notation, which I don't think you've seen beforehand, but the idea, if I connect this, okay, the inequality over here, 3 less than or equal to x less than or equal to 4. This is saying the numbers between 3 and 4, all numbers that are greater than 3 and less than or equal to 4. This is the interval notation, okay? This is saying the numbers from 3 to 4. Your interval starts at 3, ends at 4, and that's what we're going to practice writing. Now, interval notation, trying to show you the difference there, can use the square brackets, or like when you get down here, sometimes it will use the parentheses when it's not equal to. And so when we go through the examples, I'm going to show you. You've got some examples here to look at, but I'm going to focus on showing you as we, teach it as I go here. But one thing I need to make sure of. Some of you are going to say, really, Mrs. Sargent, you're teaching this? Some of you are going to say, oh, thank you, I needed that reminder. What symbol is that? Less than? Do we all know that? Do we all remember that? Do we need the reminder? I'm going with some of you need the reminder. And why do I say that? Because every time I teach this, some people need the reminder, okay? So feel free, write this in your notes as your reminder, That is the less than sign. It's the one, I always think of it as, okay, if I get sloppy with my less than sign, what did I just write there? Is that a less than sign or is that an L? I don't know. It's sloppy, right? Okay, so, but that's my way to remember, is that the less than sign kind of looks like a sloppy L, if you ask me. So that's less than. If that's less than, that means this one is greater than. It was easy in elementary when you learned them because it's eating the bigger number, right? That was easy. But now we have x's. So when you have an x and a number, it's not which one's bigger or smaller. You have to know which sign is which. Not as important, but what happens when I put that little line under it? Yeah, so this is less than or equal to. So again, make yourself a little chart here as a reminder. It will definitely help you. And then, of course, reverse it, and we've got greater than or equal to. Okay? So I would definitely encourage you, have those on your paper as your reminder. If there's any chance at all you might confuse them. Okay? When you're ready, you can flip to the next page. Oh, the one other thing, when we talk set notation, we won't use the infinity signs in set notation. We'll focus more on just the less than and greater than stuff. Okay, so, and again, I'm going to explain that as I go because it's just easier to teach that part as I go. Okay, we have some graphs here. And with these particular graphs, we're going to talk domain and range. Now, in these cases, there's equations, but I've also provided you the graphs. One of the things we'll talk about on Tuesday when I get you guys set up for Savas is we'll also look at Desmos. And I'll show you how you can look at some graphs on Desmos, because there are some graphs in this first chapter that they assume you remember what they look like, but yet we haven't taught them this year in Algebra 2. It's kind of backwards how it's set up. So, like for instance, do you guys remember what an x squared graph looks like? Well, you're looking at it. It's that U-shaped parabola. Okay, you learned it back in Algebra 1. But that's been 2 years ago, and you don't necessarily remember it. So, and I will say before I go any further and forget, I don't have the arrows on there because I didn't get them put in the computer, but that graph is going on. Okay, so that is a x squared graph, moved down 3. We'll talk about that type of graphing a lot this year. We're going to talk about, I'm going to start with domain. Now, what did we say on the front? Domain are my, which values? X. Okay, so it's the X values. Which one's my X-axis? X-axis is the horizontal axis. Y-axis is the vertical axis, right? So if x-axis is the horizontal axis, that means x values run left and right. So when we're talking domain, I want to talk about how far left does this graph go? And then how far right? So how far left is this graph going? Forever? Now, we might argue that if I didn't put the arrow on there, right? Okay, but I did put the arrow on there. As it's going up, what's it also doing? It's also going farther left, yes? So it's going forever. What's the word forever? Infinity, except this is infinity to the negative direction, so I'm going to say negative infinity. Okay. How far right is it going? Infinity also, because as it's going up on the right, it's also getting farther right. Okay. Ways to write that. One way to write that is with set notation. Now, it's going to be fancy. I'm not holding you responsible for writing it as much as just being familiar with it. Okay, so when you walk into some testing situation, you aren't like, what is that crazy thing that I see? So the set notation. Officially, the set notation starts with the curly brace. Do the best you can to write them. And then it starts with whatever variable you're talking about, which is x. And then a vertical line. So this is just saying x such that. Now, in this case, we just said it goes from negative infinity to positive infinity. So what I'm going to write here is just that we can talk about being all real numbers, or the fact that this could be just written as x is a real number. Okay. Another way you might see this stated or written is all real numbers. Okay, you can also see it written like that. Now, that's not a hashtag, right? I'm not on social media right now. That's not a hashtag. That's a number sign. Officially, it's called a pound sign, but it represents the word number, yes? That's just, I like to use that a lot because it's a lot easier than writing out number. So I just don't want anyone thinking, why is she talking hashtags? So, okay, so you could say all real numbers. You could say x such that x is a real number. Those would be ways we can't really write an inequality. So those are your inequality ways. Okay. The other option is interval notation. How far left did we say this go? Where does it end? Negative infinity. So we could say, okay, it goes from negative infinity to comma. How far does it go on the right? Positive infinity. Now this is interval notation. And this is where you put parentheses or brackets. Infinity symbols always have parentheses around them every single time. Okay? And that would be your interval notation. We're going to work with both. I'm going to get you comfortable with both. Now, as I said, the set notation, when it comes to like a quiz or a test, I don't require you to, I'll let you pick and choose what you write, but I'm not going to worry about the set notation so much. That's if you walk into the SAT, the PSAT, and you see a problem like this, that you're not freaked out about all this fancy stuff. You can just look past the fancy stuff and be like, oh, that's just X's real number. Okay. Okay, that's domain. Let's talk range. Well, domain is how far you go left or right. So range is how far up and down. Okay, it's your y values. It goes with the y-axis, how far up and down. What do you guys see in here? Something about -3? What about -3? Yeah. That's the lowest point. By the way, can we agree with that it's -3 and not -4? Do you see? I agree with the -3. You have to watch that labeling, right? Really easy. If you're thinking -4, I'm not surprised because it's easy to do. Okay, so it goes as low as -3. How high does it go? Goes infinitely up. Now, okay, I'm going to skip the set notation for a moment. Let's do interval notation. Domain, we go left to right. Range, we go bottom to top. Okay? So how low? The lowest point it went to was -3. Comma. Where does it end? How high does it go? Infinity. Now, we have to put parentheses and or brackets around. What did I already say? Infinity always uses parentheses, so it's going to end with a parenthesis. Now, the -3. This has to do with, okay, does it touch the -3 point? Does that graph go through the value of -3?
Yeah.
Yes, it goes through that point, what? 0, -3. So it goes through -3. So we're going to use a bracket. A bracket is what you use when it's less than or equal to or greater than or equal to. So when there's an equal to part there. If it didn't touch -3, we'd talk parentheses. Okay, so that's your interval notation. It starts at -3. It ends at positive infinity. Now, let's talk about writing this as an inequality. What is this as an inequality? Obviously, it's going to be in relation to -3. Where's the graph in relation to -3? Less than or greater than? If we start at -3, the rest of the graph goes up from it. -3 was the lowest y value, so this is going to be y values that are greater than -3. Could they be equal to -3? Did my point touch -3? Yes. Okay, I'm going to use the fancy set notation. I'm going to use the brace, a little squiggly brace. Now, I'm going to change from x. I'm going to have to use y because we're talking range, and range talks in terms of y. Y such that. Okay, that's just the fancy notation. Now, what did you say? Greater than or equal to -3, so we're going to say y greater than or equal to -3. And then you end the brace there. Okay? Now, as I said, I want you to be familiar with the set notation. I want you to be able to recognize set notation Savas. When it comes to what you write on a test, for me, I'd be happy with just y greater than or equal to -3. I don't necessarily have to have the fancy set notation. Or you can go interval notation. Okay? Savas will be nitpicky about what they want. I'll be kind of flexible as long as you have a correct way to express it. And we'll talk about that more when the time comes. Okay. Questions on that one? Okay. Let's talk our second example. Now, the first one was an x squared. It was the U shape, the parabola. This one is a V shape. V shape goes with what type of equation? Do you remember what those bars are? What are those straight bars called? Yeah, my first hour blank too. Absolute value bars? I say it and everyone's like, oh yeah, I knew that. But yeah. So absolute value bars, okay? And this is a V. Like the other graph, it extends. Okay? So let's talk domain. Domain, is it x's or y's? X's. Remember, your horizontal axis is your x-axis. So x-axis goes this way. So how far left and right does my graph go? How far left does it go? As it's going up, it's going infinitely left. How far right does it go? As it's going up, it goes infinitely right. So what could I put as my domain? Okay. X is a real number. All real numbers. Negative infinity to positive infinity. Same answers, right? Okay, so you could say, we could use set notation, x such that x is a real number. Whoops. We could have also said all real numbers, or interval notation, all real numbers, infinitely left to infinitely right, which is negative infinity to positive infinity. Okay, all are acceptable answers. Okay. Start thinking about range when you're ready. Range is the y values. Y-axis goes up and down, so now it's how low and how high does my graph go? What are you thinking?
0, infinity.
Do we agree or disagree? You should agree. Okay, now, some of you out there are thinking 4 though, aren't you? I can guarantee it. Okay, it's a common wrong answer. Why did he use 0 and not 4? If we're looking at that point, what is that point? That point is the ordered pair 4, 0. We're talking range. Do we need the x value or the y value? We need the y value. So it goes as low as 0, yes? I know there's a 4 right there. It's misleading. That's the x value. I don't need the x value for domain. Okay, so if we jump down here to interval notation, this graph goes as low as the y value of 0. It goes as high as infinity. Okay. What do we put on 0? Parenthesis or a bracket? A bracket, because does this touch 0? It does. It touches the ordered pair 4, 0. Infinities always use parentheses. I'll keep saying that, so hopefully it'll be stuck in your head when you go to do homework, right? Okay. Range. Well, I'll start it off for you. The fancy brace. We're going to use y such that. What do we say now? What do you think, Jackson?
Y is greater than or equal to 0.
Okay. Y greater than or equal to 0. Okay. Okay, questions on that one? Okay. Let's try our last one in this section. Now, notice the shape looks familiar to the first shape, doesn't it? It should. It's an x squared equation. It's a parabola. The difference is upside down. Okay. It's not going to change a lot of things, let me tell you. What are your thoughts about domain? We're doing left, right, or up and down? Domain is how far, which directions? Left and right. Okay, it's the x value, so how far left and right? How far left does this graph go?
Negative.
Yeah, as it's going down, it's going farther and farther left. How far right does it go? As it's going down, it's going farther and farther right. So, you just said interval notation, yes? It starts at negative infinity and goes to positive infinity. And infinities always use parentheses, okay? Or how about it's the same as the last two problems we did, right? Okay, so it's also all real numbers, or x such that x is a real number. Okay. Okay, what about range? Are you thinking about it? How low does this graph go?
Infinity.
It's going down, right? So infinity, and if we're talking about it going down to infinity, that is negative infinity. How high does it go?
4.5.
I think so. This is where you see me put the labels on here to help us get it figured out, right? So every other line is a label again. So that is the height of 4.5. So what do we say? If I do my interval notation first, I seem to keep doing this first. We went as low as negative infinity. Negative infinity is always going to use a parenthesis. It goes as high as 4.5. Did we touch the point at 4.5? Yeah. So it uses a bracket. Okay. How do we write this as an inequality? This is all numbers that are what in relation to 4.5?
Less than or equal to.
Okay. 4.5 is the highest, so it's all numbers below there. So less than or equal to. So I'm going to say the fancy brace, y such that y is less than or equal to 4.5. Okay. Okay, so that's domain and range. That's something we'll be working on. Domain and range is one of those themes that kind of sticks with us throughout the year. Okay, so we'll keep working at it and it'll get a little bit better each time we work with it. But that is definitely something that keeps coming back a little bit here and there. Okay. Questions I should answer? Okay. I think this is where I decide, do I keep going? Do I stop? But I think I'm going to go a little bit farther. Just means we might have more free time a different day. And here's where I'm at. This is my morning class is done at this point. So my first hour didn't get past this point. In fact, we didn't get to that last example even. But I'm not going to keep going. We're going to go one more topic here. X and Y intercepts. I would argue that you've done X and Y intercepts. Again, not expecting you to remember them, but I'm going to argue that you've done them. Do you remember what we mean by intercepts?
Where it crosses the x and y axis.
Yeah, when I talk about an x-intercept, it's where it crosses the x-axis. Y-intercept, where it crosses the y-axis. So the x-intercept, officially I have up here the x-coordinate of a point where the graph intersects the x-axis. Now, vocabulary, I'm throwing in this word zeros because x-intercepts are also something called zeros. We'll talk about that more as we go along. But if you're asked to find the zeros of a graph, you're asked to find the x-intercepts. And then y-intercept, the y-coordinate of where the graph crosses or intersects the y-axis. Now, our goal is to find the x and y-intercepts. If you think about an x or a y-intercept on the graph, like if we look at the graphs we just did here, what about these ordered pairs that fall on the x or y-axis? What number is always involved as one of the two numbers? A zero, yes. This involves a zero in the y. This would involve a zero as the x. So you'll notice on here, my hint, substitute zero in place of the other variable. Anytime you're asked to find an intercept, if you want to find the x-intercept, then y is going to be zero. If you want to find the y-intercept, then x is going to be zero. So you're always finding to find the intercept, you're always using 0 in the opposite variable. So if I start by finding, let's start by finding the x-intercept. And I'll label it as such here. In order to find the x-intercept, if it's on the x-axis, it has an x value. But what do we have to know? We're going to let y equal 0. And so when I say let y equal 0, I'm going to write out the math. It's usually pretty easy math. But y is 0, find x. So in this equation, if I put 0 in for y, we're going to have what? 0 equals the absolute value of x minus 3. Okay. Basic equation solving skills. How do we solve for x?
Three to both sides.
Add 3 to both sides. Does this sound familiar? If you're trying to get the x by itself, if it's minus 3, officially we're going to add 3. So then we end up with 3 equals the absolute value of x. Now, what I'm going to ask you to think about. What are my answers?
3 or negative 3.
Okay. You guys agree with that? 3 or negative 3? Obviously, if it says absolute value of x equals 3, 3 is an answer, right? Why negative 3? Why negative 3?
Because the absolute value of negative 3 is just 3.
Okay. And if you remember, absolute value is the distance from 0. Okay, that's our official definition. How far is negative 3 from 0? It's also 3 away. So this is one of those unique things where x could be positive 3 or negative 3. So you'll see I just wrote x as plus or minus, x equals plus or negative, plus or minus 3. And what I have written out in my notes, my x-intercepts are 3 and negative 3. Okay, I don't care how you write it out each way, whether you write a plus and minus 3 or a 3 and a negative 3. Anytime you see that absolute value, you have a possibility of having 2 answers. Now, those are my x-intercepts. What do we also have to find? Y-intercepts. How am I going to find where it crosses the y-axis? I'm trying to find a y-intercept. What do we know about x? It's going to equal 0. So now, go back to your original equation, put 0 in for x. So y equals the absolute value of 0 minus 3. What's the absolute value of 0? 0. What's 0 minus 3? Negative 3. Is it okay that I only have one y-intercept? Yeah. I'm not saying you couldn't have 2, but it just so works out that way. So my y-intercept is negative 3. X-intercepts were positive 3 and negative 3. Coincidence that they overlap with the 3's. Okay. One last example for the day. G of x equals 4 minus x squared. Now, what is this g of x thing? It's similar to saying f of x. And what is that another name for?
Function.
It's a function. What variable can I replace it with?
Y.
Yeah. This is the same as saying y equals. Okay, so anytime you see something like g of x, f of x, think of that as that equation being y equals. Okay, I don't want you to get stuck with, I don't have y, I don't know what to do. Okay, let's start by finding our x-intercept. How do we find the x-intercept?
Y equals 0.
Yeah, y equals 0. So put that in our equation. 0 equals 4 minus x squared. How would you like to solve that?
Add the x squared on both sides.
Okay. And I agree with adding the x squared because that's going to, since it's minus x squared, when we add it over, that's going to make it positive, right? And I don't always write this stuff out at this level, but I don't know you guys yet. So I'm going to add it in. So when we move that x squared over, we end up with x squared equals 4. What's the final step to solving this? Nellie?
Take the square root.
Take the square root. Okay. And you could also just ask yourself what numbers make this true. But you take the square root officially. X squared becomes x. What about the square root of 4? What is the square root of 4?
2.
And?
Negative
2. Could we use positive 2 or negative 2 in this scenario? Yeah. 2 times itself, 2 is 4, or negative 2 times itself is also 4. So we just came up with 2 x-intercepts again. It won't always be 2 x-intercepts, okay? It just is working out that way. So x-intercepts of 2 and negative 2. Okay. Let's finish this problem up with finding our y-intercept. Remind me, how do I find my y-intercept?
Let x equal 0.
Yeah, you get rid of the other variable. You're always just getting rid of the other variable to find intercept. So x equals 0, y equals 4 minus 0 squared. And 4 minus 0 squared is 4. So we have a y-intercept of 4. Okay. That is a good stopping point for today. The advantage is that puts us closer to the end. I don't know, maybe I'll play it by ear and play it class by class. Maybe I'll let you guys get into the homework on Monday. Although if I do that, then that kills my lesson plan for Tuesday. So, I don't know, maybe I won't. We'll see.